Hey guys, today I'm going to show you this little example of this little experiment. So pay attention to what's happening. Notice that the height of both of those and the base are the same size. Notice how many times this is filled up with that liquid. So just pay attention to that as it moves through, and for the next examples, how many times are they filling this up? Same base, same height. Hi guys, hopefully that experiment was helpful for you to see that you could break either a prism or a cylinder into thirds. So a cone and a pyramid end up being a third of the volume as the prism or cylinder. Yep, took me a second there. Here is just another illustration of that same thing. You have this triangular prism and you can see it broken into these three separate parts and then separating those. So if you want to write down like a little description of the experiment, you could say the volume of the prism is 3 times the volume of the pyramid. Or you could replace the word cylinder there, and cone for pyramid has that ratio of 1/3. So the formula will reflect that for each of these. Volume of a pyramid, the volume equals 1/3 the area of the base times the height. This is the formula for volume of a prism, and then you take 1/3 of that total volume. Or if you'd rather divide it by 3, that'll be the same thing. So let's go to some examples of this. Finding the volume, rounding to the nearest tenth. For this first one here, it gives me the area of the base. So it's just kind of nice. You don't have to do half the apothem times perimeter. Here they just give you the area of the base, and the actual height is 5, and that's also what you need for the formula. So the volume is going to be 1/3 the area of the base times the height. So then you can just grab a calculator, whoops, drop your calculator, whichever you prefer. So we have 22 times 5, and then 1/3 of that. We get 36.6 repeating, or you could round it to be, oh, I guess it does say round to the nearest tenth. So let me go ahead and change that then to be 0.7. This is volume, so that'll be cubic centimeters. For this next one, this is a right triangle, so the area of the base is going to be half of 15 times 6. So when you multiply that together, that's 45. And the height of that pyramid is 14. So volume equals 1/3 times the area of the base times the height of the prism, or the pyramid in this case, sorry. So we have 45 times 14, and it's 1/3 of that. So the answer would be 210, and that's cubic feet. So make sure you're getting these on your calculator too if you're just watching this. Make sure you know where these numbers are coming from and you're trying it on your own also. This next picture down here is just to illustrate that we could have a pyramid or a cone as long as they're the same height. It's just going to be 1/3 of the total volume. So we have the same formula going on for those. Just wanted to put that on there as a little visual for you. So for volume of a cone, you usually don't see it written out as 1/3 area of the base times the height because the base is a circle. So usually the way you see that written is 1/3 area of a circle is pi r squared times the height of that cone. So this would be the way it would show up on your formula sheet, but really these are the same formula. So I'm going through these examples. I know I'm going to go through them pretty quick. If you want, if you're just watching this on your own, maybe what you should do is pause it and try an example on your own and then just play through it as a double check. Most of the stuff is work on the calculator, and I can do that pretty fast. I have my calculator right next to me. If you need to pause and grab a calculator, that might be a good idea too. So this first one is 1/3 times pi times the radius, and the height is given to me. The height is 7. So I'm just going to type that into the calculator. And the directions say to round to the nearest tenth. So that one would be 66.0, and that is cubic feet. My calculator actually says 65.9734, etc. So remember, when you're rounding, if that needs to then round this up because you can't make that 10, you go ahead and do that. For this next one, they give me the radius and the height as well. So 1/3 pi times the radius squared times the height. And I'm going to type that into my calculator. What I usually do, because I don't like doing the fraction button for the 1/3, is I usually type everything else in and then just divide it by 3. Whichever way makes more sense to you, or whichever way you want to use is fine. So 1005.3, and that's cubic centimeters. This last one, it doesn't give me the radius. I don't know why it has the 30 degrees up here. Let's go ahead and take that 30 degrees and cross it off and put 30 degrees down there. So you could set this up with tangent if you want to. Tangent of 30 equals x over 5. You end up multiplying 5 times the tangent of 30. So that radius would be 5 radical 3 over 3, or as a decimal, 2.8868. The way I got this is I divided by the square root of 3 because it's a 30, 60, 90. So either way, it doesn't matter to me which way you're using to solve. Volume is 1/3 times pi times the radius squared times the height, or that 2.88 number. So when I multiply this out, .6 cubic centimeters. And then this last example says, on top of the Washington Monument is a small square pyramid called a pyramidion. This pyramid has a height of 55.5 feet with base edges approximately 34.5 feet. What is the volume of the pyramidion? Round to the nearest tenth. So if you've ever been to Washington, D.C., or maybe just seen a picture, you have this pyramid. And again, I don't think this lets me do dotted lines, so I'll just do this as like a different color. And you have that point on top. This would be like the very top part of the Washington Monument. That's that really tall building. It says that the height, which would be this part coming straight down, is 55.5 feet, and it is 34.5 feet as the base edge. So the volume of this would be 1/3 the area of the base times the height. The area of the base is going to be the area of that square. So that's 34.5 squared. So 1/3 the area of the base, which is 1,190.25, times the height of this pyramid, 55.5. So I'm just going to take my calculator and multiply that together. The volume would be 22,019.6, and that is cubic feet. So this does sound like a really big number, but this is, again, the top of that monument. Google Washington Monument if you're not sure what it looks like, but you know it's the one that basically looks like this, the really tall building in Washington, D.C. So there we go. I hope this is helpful, and we'll work on this in class.